Now we're going to look at how to use the trigonometrical functions to find our angles. If there's a missing angle in a triangle, we want to find it, we can use our trig functions. So if we look at this triangle here, we have an angle theta, and then we're asked to find the angle theta there. We've got two sides, one side 8 centimeters and the other side 10 centimeters. So what I would do is, label those sides. If you look at it, the longest side is this one, the 10 centimeter side, so that's the hypotenuse. This side here is the one that's far away from theta, is the one that's opposite theta, so that's the opposite, and then the final one here is the adjacent. So now our information is on the opposite and on the hypotenuse, so we want a trigonometric function that links opposite and hypotenuse. Now if you know your toe, right? Opposite and hypotenuse are linked by the sine function, right? So S is for sine function, so they are linked by the sine function. So for me, I will then quote the sine function or the sine relationship, which is sine of theta is equal to opposite over hypotenuse, right? Sine of theta is equal to opposite over hypotenuse. So what is our opposite? What's our hypotenuse? Our opposite is 8, our hypotenuse is 10, so I can continue and say sine of theta is equal to 8 over 10, right? Because 8 is our opposite and 10 is our hypotenuse. Now note that I'm not looking for sine of theta, I'm looking for theta. So I still have to remove this sine here. If I remove sine and take it to the other side, I'll get the sort of the reverse of sine, which is arc sine. Arc sine. So arc sine is denoted by putting a little power minus 1. So if I put a little power minus 1 on sine, it's not sine, it's now arc sine. So theta is arc sine of what was there? 8 over 10. 8 over 10. So this is, you give this to your calculator, right? For you to get arc sine for most of your calculators, you need to press the shift button or the second function button first before you press sine. So if you press shift sine, you get arc sine. Press second function sine, you get arc sine. So that's what most calculators do. All right. So if you submit that to the calculator, arc sine of that should give you 53.1 degrees. 53.1 degrees. So we found our angle there. So let's try another example. Okay, here's another example here. This time we have an angle alpha, and alpha is just another Greek letter that we use to denote or identify angles. So now for this triangle here, the hypotenuse is this one, and then this 4 is opposite alpha, so this is the opposite, and that's the adjacent, right? So in this case, our information is on the opposite and on the adjacent. There's nothing here on the hypotenuse. So we want, looking at our toe, right? We want something that links opposite and adjacent. So opposite and adjacent are linked by the tangent function, right? So I can quote the tangent function's relationship using my alpha. Tan of alpha is equal to opposite over adjacent. So opposite over adjacent, right? And substituting the actual values of opposite and adjacent, I can say tan alpha is equal to, my opposite is 4, my adjacent is 6, right? And note that we're not looking for tan of alpha, we're looking for alpha, so we have to remove tan. So we take tan to the other side, it becomes the reverse or the opposite of tan, which is arctan. And again, you put a little power minus 1 to denote arctan. So arctan of 4 over 6, you submit that to your calculator, right? Second function tan or shift tan, then you get your answer is 33.7 degrees. All right, so now let's go to our final example. We've got this situation here. We have an angle gamma, and gamma is just another Greek letter, right, that we use to denote an angle, or to identify an angle. So if we look at our triangle here, this is our hypotenuse, the 11, the opposite is that one, and the adjacent is that one. So our information is on the adjacent and it's on the hypotenuse. So if you look at our SOHCAHTOA, we're looking for something that forms a relationship between adjacent and hypotenuse. Adjacent and hypotenuse. That's going to give you the cosine function. So if we quote the cosine function using gamma, cos of gamma is equal to adjacent over hypotenuse, right? And then from there, we can plug in the actual values, right? Cos of gamma is equal to my adjacent, which is 7, my hypotenuse, which is 11. Now, we're not looking for cos of gamma, we're looking for gamma. So we remove cos, take it at the other side, it becomes arc cos of 7 over 11. Again, if you submit that to your calculator, you will get 50.5 degrees. Okay. So that's it on trigonometry.